Tire pressure and fuel economy. Often has the question been asked, but how much of a difference does it really make? How much fuel can you save by keeping your tires inflated to the proper pressure, and what kind of environmental impact might it have? To check on these numbers and to see if we can actually see some fuel economy and environmental savings, we'll take a look at a fuel economy estimate based on tire pressure and a resulting CO2 emissions index.
To quantify the effect that underinflated tires have on fuel economy, MPG calculations can be compared between a car with properly inflated tires and that same car under the same conditions with underinflated tires. A very useful example can be constructed using a mid-sized car and typical drag, frictional, and powertrain efficiency parameter values for a gasoline spark-ignited vehicle. To calculate the fuel economy of a car with properly inflated tires, we will use a tire pressure P high of 2.5 bar or around 35 psi, which is on the upper end of the recommended tire pressure range for a mid-sized car. And to calculate the fuel economy of a car with underinflated tires, we'll use a tire pressure P low of 1.5 bar or around 22 psi. For context, 1.5 bar would be a tire pressure on the verge of noticeable underinflation. In normal conditions, you could likely get on the expressway and maybe not notice this degree of underinflation. P high and P low are used to calculate the respective rolling resistance coefficients mu for the two cases of proper inflation and underinflation, and then the rolling resistance coefficient is used to calculate the respective fuel economy for the two cases. Annoyingly enough, SI units are the most common units for measuring the parameters associated with fuel economy, yet MPG is the most common, easiest to comprehend measure of fuel economy. Because America. Once we carry out the fuel economy calculations, we see that relatively insignificant or unnoticeable perhaps underinflation can result in quite substantial changes in fuel economy. For our particular calculations, there is around a 3.5 mile per gallon loss due to underinflation. There are approximately 220 million licensed drivers within the United States, and that the average annual mileage of a driver is around 13,500 miles. Additionally, the National Highway Traffic Safety Administration tells us that anywhere from 27 to 32% of drivers are driving with at least one underinflated tire, and that 2 to 8% of drivers are driving with all four tires underinflated. So if we assume a car for each of these licensed drivers and multiply that by the percent of the population is driving with four underinflated tires, there are roughly 10 million cars with underinflated tires in the US.
Using only the conservative estimated percentage of cars with all four underinflated tires, the national average of 13,500 miles driven per year per driver, and the miles per gallon differences created by the lower tire pressures, we conservatively estimate that 135 billion miles are driven every year on underinflated tires in America, resulting in 654.7 million gallons of gasoline being unnecessarily consumed. This wasted gasoline has an obvious economic cost that we hope will incentivize drivers to pump up their tires. An average driver with underinflated tires will waste $194 on gas every year. This cost could be significantly more depending on your local gas prices. Nationally, with 10 million drivers going around with underinflated tires, America wasted $1.94 billion on gasoline whose energy went straight into the ground instead of propelling us to our destinations. Perhaps even more importantly, this wasted gas comes with a hefty greenhouse emissions cost. Assuming complete combustion of isooctane, we estimate that number to be about 5.7 mmmt. That's million metric megatons. And according to the U.S. Energy Information Administration's 2017 figures, this CO2 source would account for 0.1083% of all energy-related CO2 emissions. In an era where we are making every effort to replace current energy sources with less damaging ones, finding simple ways to improve our efficiency and cut back on energy use while improving the durability and performance of our vehicles is a no-brainer, and we hope our efforts have encouraged all who watch this video to take 2 minutes to check their tire pressure next time they stop for gas.